Hello and welcome back. So today we will be discussing about the quality control of an RDP. So a random donor platelet is produced either by a buffy derived method or by a PRP method. So at our center, we are doing it by buffy derived method. Hence, we will be taking you through as to how to do a quality control of a buffy derived RDP. So I have Dr. Raji with me who is going to demonstrate the entire procedure, and it is a very commonly asked questions during the practical examinations for the MD and the DNB students. So over to you, Dr. Praj.
These are the DGHS quality requirements of random donor platelet concentrate prepared from buffy depletion method from 450 ml of whole blood. Appearance: swirling should be present. There should not be any visual RBC contamination or discoloration. The volume should be 70 to 90 ml. Platelet count should be more than 6 into 10 to the power 10. pH should be more than 6. RBC contamination should be traces to 0.5 ml. WBC contamination must be less than 5.5 into 10 to the power 7, and sterility is checked by culture. We are going to demonstrate the quality control requirements of a random donor platelet produced by the buffy method. We will select one random platelet concentrate from the platelet agitator. As we inspect the platelet concentrate, we can see that swirling is present. It can be seen against light. There is no visual RBC contamination and no discoloration. For volume calculation, we will place the platelet concentrate on the weighing scale. Volume of platelet is calculated as weight of the full bag minus weight of the empty bag divided by the specific gravity of platelets. Here, weight of the full bag is 115 grams and weight of an empty bag is 29 grams, which when divided by the specific gravity of platelets, which is 1.04, gives a volume of 82 ml, which is in the range of 70 to 90 ml. We will mix the bag gently 3 times, and using a stripping device, we will take an ideal sample into the segment. Using a sealer, we will remove the segment from the platelet concentrate bag. Now we will use an EDTA vial and label it with the platelet concentrate bag number. Using a hammer type segment device, we will gently squeeze the content of the segment into the EDTA vial so that the EDTA tube contains a representative of the platelet bag, which will be used to do the QC. Using Coulter automated cell counter, we will do the CBC of this given vial, check for the red blood cell and the white blood cell contamination and platelet count of this bag. These are the results of the CBC done of the platelet concentrate sample. To calculate the platelet yield, we will multiply the platelet count into 1000 into the volume of the bag. Here, as we can see in the Coulter results, the platelet count is 786.4 into 10 to the power 3 multiplied by volume of bag, which is 82 ml into 1000, which gives us a platelet yield of 6.44 into 10 to the power 10, which is more than the QC requirement of more than 6 into 10 to the power 10. The RBC contamination is calculated as hematocrit divided by 100 into volume of the bag. Here in the automated cell counter result, the hematocrit was 0.1 multiplied by volume of bag, which is 82 ml, which gives an RBC contamination of 0.082 ml, which is traces, and less than 0.5 ml. To calculate the WBC contamination, we will multiply the WBC count of the bag into volume of the bag multiplied by 1000. Here WBC count is 0.19 into 10 to the power 3 multiplied by 82, which is the volume of the bag into 1000, which gives us the WBC contamination as 1.55 into 10 to the power 7, which is less than 5.5 into 10 to the power 7 as specified by the QC. For checking the pH of the sample, we will take one drop and place it on the pH indicator strip. Now we will match it with the color coding as given to see if the platelet QC is fulfilled or not, which is pH more than 6. As we can see here, the pH of this platelet sample is in the range of 7 to 7.5. To check sterility by culture method, we will place the platelet concentrate for QC into a laminar airflow chamber known as laminar hood. We will transfer few ml of platelet sample into anaerobic as well as aerobic culture bottles. The samples are sent to microbiology lab where they will be incubated for 72 hours and 14 days, and they will be checked for sterility. As we can see from the results, after 2 weeks of incubation, there was no bacterial growth in both aerobic and anaerobic culture sample.